All right, let's get going, everyone. So, welcome to the Collada Meetup here in San Francisco. So we have the committed crew here. So we should actually use this opportunity to discuss the real issues and stuff that we have going on. But we have a lot of good progress to report on too. So I've put together a short State of the Union, and then we're going to hand over to people who actually know what they're talking about to give us more details. So we're going to cover the update to the OpenCOLLADA project. Uli is here to talk about that. glTF, we have Fabrice and Patrick here. Remi, how do you pronounce it? Is it Flair?
Forget it, it's not me.
Flair.
I don't know.
I think it's Flair.
European guys.
Wait, you're European.
Oh yeah, that's right.
Do you have the video?
So the Flair Unity Cloud Exporter and then discussion. So without further ado, actually we had this meeting last year and we had a good discussion. We came up with a action plan and we've almost completed everything. So we agreed we're going to have closer cooperation. We opened up a mailing list. We decided to focus on OpenCOLLADA, and we've actually delivered upgraded OpenCOLLADA, which we'll have more details on. We wanted to track conformance. We've made good progress in putting the conformance tests up on GitHub, along with the instructions on how to use it. I think that's where we have a little bit more work to do. We had this point last year that we thought that not everyone uses all of Collada, and so perhaps a useful subset would be good. We haven't really done anything on that, so I'm interested to have that discussion whether that's still necessary or not. We said we were going to build synergy with WebGL, and now we have the glTF project that we'll talk about, and the compression streaming folds into glTF as well. So it almost looks like we're organized doing stuff. And the big piece of news we formally announced, I mean it's been here for a little bit, but we formally announced it this morning at 6 a.m. that Collada is an ISO standard. So good longevity and confidence for people who want to use Collada as an archival format. The fact that ISO are now publishing a copy of Collada doesn't mean that Collada changes. It's exactly the same document, just with the front cover. And if you want to buy it from ISO, you have to pay money. But it means it's going to be there for forever, basically, which is good. So the outreach. So how many people here are signed up to the public Collada mailing list? If you haven't already and you want to engage in a discussion, it would be good to have you guys on there. If you go to collada.org, the instructions for signing up are there. I mean, for those of us that are on it, is it useful? Are we getting any substantive feedback on the public mailing list?
I think we had some discussion, and it was on the WebGL, but on the public, no, Kada.
Okay. Yeah. Well, we should, and the working group should remember to take some of the discussions out to the public list,
Yes.
where we need the community feedback.
Good afternoon, everyone. Uli Klumpp with Micro Software. This was going to be a separate section, but decided to keep it short and just squeeze it into Neil's presentation. One of the big action items from last year when we met here was to do a significant upgrade to OpenCOLLADA, and we took the feedback into account that we got in the session here last year. The first piece of feedback, actually, are you familiar with OpenCOLLADA before I go into details?
Give the 2 minutes summary.
Okay. It's a library that you can use for importing and exporting Collada, stream-based. It can be in your tools, in your final delivery projects. You can build really great components for pipelines on it, and we'll hear a little bit about that within the context of the glTF project. Actually, Fabrice did some pretty impressive work with that. And it's also well known because there are plugins built with OpenCOLLADA for 3D Studio Max and Maya as an alternate solution for whatever's provided with those products. So that's kind of a good example of the different ways of how OpenCOLLADA, the library, can be used in plugins for DCC tools, in custom pipeline components, or in whatever else you might be building. So it's available as open source on GitHub, and that actually was one of the first sub-action items to this upgrade that we took away from the conversation last year. We were on Google Code before, and there was feedback that it would be easier to get involved with development of OpenCOLLADA if it were over on GitHub. So we moved that over, preserving all the history and the bug reports and whatnot. Then the next step was to actually jumpstart the development again. It had gotten a little slow, there wasn't as much progress, there were a lot of issues filed. And Khronos committed to jumpstart the development by essentially putting a contract together that would allow the addressing of the most important known issues that there were with the library. And I think we were able to cover all the really serious issues. There might be still a few that need to be addressed, but overall I think it's a major step forward in terms of robustness and reliability. So that work just got completed. You can look at the commit logs over on GitHub. It's all done in the open, and we were able to put some pre-built binaries together as well, namely of the popular 3ds Max and Maya plugins. So you can go and just follow the source code and grab that and fork that if you want for your project, or if you just want to go into the DCC tools, you can also grab the pre-built binaries. The plugins have seen a major upgrade in the sense that they now support the latest versions of those tools, which was very frequently requested. And we also were able to set them up to run the conformance test suite with them, which is a great basis for further improvements going forward, because it rapidly allows us to determine how good are they right now, what else needs to be done, and that applies to the library underneath as well. So a lot of great progress has been made over the year. We're very proud with the step forward, but it's really a first step. We've seen already a lot more community involvement during this process as the momentum picked up, but we really want to ask for more. I think ultimately this needs to be a joint effort between everyone in the working group, between Khronos and the community, to really evolve this to the level where we would all like it to see. So that's the big ask here on the slide. Please get involved, and let's work together to make this great.
So how much of the conformance tests are we passing so far?
I don't actually have that number right now. I wasn't actually directly involved in the upgrade project, but we're now in the state that we can determine that easily. That's
Right.
the big step forward.
And we're aiming to pass the basic.
The first step is the baseline. I think we should be able to go beyond that just by knowing what features are present and what features are working. But I think it's a step-by-step process. There's 3 levels in the conformance test, and first making sure that the basics are covered is the first step, and then given the feature set that OpenCOLLADA has already, we should be able to progress beyond the base level in the future.
Cool.
Good.
All right.
Thank you.
Thank you. So this is the other thing we took away. We had the conformance tests before the last year meeting, but they were not on GitHub, and everyone wanted them on GitHub, so we've brought them over there. And there is a conformance test tutorial, which is quite exhaustive, and that's uploaded as well. So conformance tests are available for everyone to use free of charge. So I think one of the actions that the community now needs to take is to go and canvass all of the tools vendors and point to the OpenCOLLADA implementation and the free availability of the conformance tests, and make sure people understand that there's really no longer any excuse not to have conformant I/O for any of the tools that are out there. And it's okay to do plugins, but it'd be better if Autodesk were to actually upgrade their own importers, exporters to be conformant. So we actually had a press conference yesterday where we made the announcements around the activity that we've been doing around Collada, making Collada the most portable and reliable 3D asset interchange format. We also announced some stuff around WebGL, making WebGL into the most secure and portable 3D execution platform. And it's kind of cool that the Collada working group is driving the connection between the two, which is the new project that we also announced this morning in the press release called glTF, OpenGL transmission format. So the intention is to create a standards-based content pipeline from authoring in Collada through to deployment and execution on the GL family of APIs, including WebGL, but also OpenGL, yes, and OpenGL. And we're going to talk in quite a lot more detail about glTF. And I'm going to give that the context, and then Fabrice will dive in, and Patrick with the details. So I think a number of us identified for some time there's a need for a 3D transmission format. We haven't had our 3D goes social moment yet. Audio has its MP3, and you get Napster. Video has its H.264, and they get their YouTube. When we managed to do a codec for 3D that is widely adopted, we will have interesting market opportunities occurring. We think the reason that it hasn't happened before is that the use cases for 3D are much more diverse than audio and video. If you have a video file, what are you going to do? You're going to play it from beginning to end. If you're really advanced, you'll pause it. And if you're really, really advanced, you'll seek in it. There's basically nothing else you can do. But of course, with 3D, there's almost an infinite number of things you can do with asset files. So that's probably why that hasn't happened. But we think we can make a useful first step into solving this part of the puzzle. So, obviously, Collada is a authoring format, it's not a runtime. And so today, everyone is doing their own custom converters and creating their own proprietary runtime formats. And that loses some market opportunity. From a hardware vendor's point of view, although we might be some way from this, we're not even taking the first steps towards having a hardware codec for 3D like we do for audio and video. The content has to be constantly reconverted for different platforms. We can't have portable runtime optimized content, and we can't have runtime optimized stores and repositories. So the glTF project is to create this runtime final stage format using JSON, for which the guys will describe in more detail. But I think that one of the critical enabling decisions is to define the node hierarchy in JSON. So it's cross-platform, but it's also web-friendly. But to take the asset payloads out separately from the JSON, so the meshes, the textures, the surfaces, and have them as payloads alongside the JSON. That means we can incrementally add compressed payloads over time as we generate that technology either inside Khronos or with other standards organizations in the industry, MPEG and others, for example, are interested to get involved in that payload compression activity. So this is, I won't go into much detail here, but obviously we can have a pipeline, and there's going to be a sample implementation, which is actually already in prototype form, Kada to glTF. This is what the guys will be talking about. And the next steps after this, we're not doing yet. We're consciously keeping it focused on just getting the JSON node hierarchy defined first, in a way that the MPEG guys can use it, the Web3D guys can use it, and anyone else who's interested can use it. So hopefully the entire industry can use a single JSON format. We don't need to reinvent it multiple times. But looking forward, Remi's been working on REST 3D, and we think that REST is a way to cut the Gordian knot of having a million different ways of using and compressing and streaming 3D assets by taking a web services approach to serving 3D assets to clients. The two can negotiate how you're going to stream. So a client can say, send me the low geometry data, then send me the high geometry data within this viewing frustrum, then download me the textures, and then download me the high geometry everywhere, or any combination of those two. By using REST, you can hopefully avoid some hugely complicated format that tries to bake in all the possible 3D use cases in one specification, which is completely impossible. So I think that's going to be a vital part. And then, as we were saying, payload compression and streaming. And we're hoping that we get a lot of people in the industry coming to help us around the streaming and compression. But we are committed to keep it royalty free. So let's leave this for the end. So,
yeah.
Yes, question.
What you described, is this exclusively for desktop, laptop, or also mobile?
Absolutely, across all platforms.
And will that require hardware acceleration to be reasonably effective?
The mobile, when we get to the stage of having a full-featured codec that needs the performance, mobile will want it first, because not just for the performance, but for low power. If we can get it, whatever it is, if we can get it into hardware, the power will typically be a lot more efficient in running it on the CPUs, and that's priority number one in mobile is power. So
another quick question.
Yeah.
In the WebGL world, there are things like 3JS and so on and so forth. Are they going to be sort of in the same direction as what?
Yes.
Or will it be diverging?
Yes. So you guys can probably do you want to answer that?
We actually.
If you come.
Yeah. So 3GS is a bit special case because it can actually under 2D canvas and 3D canvas. So you have to go through some transformations to pass the data through it. But with glTF, it's all raw data. So type arrays directly, and you can pass shaders. I will talk more about that. So yes, you can transform things to 3GS. There is already a loader available in the Khronos repo that we have to work a bit with 3GS people and have it integrated, so you will get this functionality for free.
Yeah, but this is a complement to it, and we would encourage all those middleware libraries to use this over time.
In general, when we look at glTF, like it's a specification, right? Where it's a spec in progress, but we see in order to get adoption, we need to have more than the spec. We need to have the tool chain, both example client loaders as well as the server-side pipeline.
Another comment, I heard a rumor that IE11 is going to support WebGL, despite their complaints in the past of being opposed to it because of security issues of all things. So just FYI.
I can neither confirm nor deny, but I've also heard positive vibes. So before I hand over, I want to announce that Fabrice is now Collada Working Group Chair. Again.
Okay, so today I will talk about glTF, which stands for Graphics Library and Transformation Format. So first, a quick overview with the status where we stand about this work. Motivations, design principle, glTF pipeline, the scope of the features, early support and adoption, and demos with Patrick. So 1 year ago, we were in this room for the same meetup, but it was more like a brainstorm at the time. And attendees, according to attendees' feedback and the interest in WebGL and the growing mobile market, phenomenal growth, then it was clear that the content pipeline should extend beyond InterExchange and Collada. So the working group decided to investigate the creation of a new optimized format for delivery on GL-based API. This project was initially called Collada to JSON, and it had successful positive feedback so far. And just a quick story about it. In just 28 hours after I posted the announcement about this project on the public WebGL list, Patrick here replied with a prototype of his engine Cesium, who adopted the format. So that is very straightforward. And he will do a demo about that just after. So motivations. First, bridge the gap between 3D formats and GL-based API. Collada solves the interaction between 3D tools, but it has never been intended to be a runtime format. So there is still a missing piece to reduce duplicated efforts in content pipeline. Every time a developer wants to display an asset with a GL API, he has to do the same kind of transformation on the data, but we'll talk more about that later. A common format for content providers. There is an emergence of content providers, services who host 3D assets. And wouldn't it be great to have not only visualization, but also reliable and widely adopted delivery format, so that you could not only visualize, but also use assets in your application from these content providers. Design principles. Streamline rendering, size, speed, and ease of implementation. Size, all the expensive data is stored in binary blob. And the expensive data are typically vertices and indices. What is left for the JSON is a node hierarchy and the higher level entities, which are typically cheap. Speed, JSON can be parsed quickly by browsers, and having binary blob gives opportunities for compressions. Ease of implementation. Whenever it was possible, the data maps directly to GL, like shaders, vertices, and array, vertices and indices. And these buffers for vertices and indices are described as typed array with properties which are compliant in JSON with the typed array spec API. So you have buffers and buffer views. So here is a pipeline, and today we are interested by actually the converter and delivery. You know this kind of pipeline, and here what the converter does is it provides an optimized glTF asset which will require minimal processing to be displayed on a GL-based API. Here is a closer look to the converter. So you can use a command line today with to access Collada to glTF possibilities, but you could also access the transformation through REST3D, and REST3D can trigger, thanks also to some prototype that Remi did, we could try that. With REST3D, you can negotiate very late what you need for your device and platform. So say you are on iOS and Android, you could get this kind of compressed texture which are beneficial for that platform. So here is some of the transformation I was talking about just before. There are some mandatory transformation you need to do to get the asset to GL API. Triangulation, unify indices, split meshes, generate shaders. And access conversions is not strictly needed, but if you want to merge things together, you have to do that. So I don't know if attendees have questions about this transformation or if it sounds new. Yep.
A side question, due to lack of familiarity, I'm not sure how relevant my question is. Do you need to worry about validating any of the data that it's transformed correctly? I'm asking that in the sense of, if you use XML, you can create a schema. Now that doesn't necessarily warrant doing that, but you wouldn't have that with JSON. I guess that's not an issue, is that correct?
Yeah, so your XML is great for validation, right? Because you can make a really strong schema and you can validate against that.
And in this case, it would probably be fairly light as well.
Right, so that's true. So for JSON, we actually do have a schema for this, so there is a JSON schema. Now, however, JSON schema is not as rigorous as an XML schema. So although we do have the schema and we do have standard tools to validate it against it, I still believe that we're going to need to build additional tools to really do conformance testing.
Yes. And in addition to validation, we need also the coherency, which you have to do anyway with XML2. So, and there are some more plain optimization. Some are already there, some not, and they are important. The most important one here is to flatten hierarchy and combine meshes when you can do it. So it's big improvement for performance. And of course, compressed meshes. Scope. So for 1.0, the scope is to get the node hierarchy, to specify the node hierarchy, geometry, materials, light, shaders, and cameras. Also animations and skinning. And we also have active talk about mesh compression with partners, so we will keep you updated about that. The target feature complete draft is for the late summer 2013, for this summer, and we hope to have some news around CGraph. But we are in a process which is a bit new. We have the specification in the open, so it's important that everyone give feedback about the specification, so we are sure that we don't miss any important feature which would be important for everyone. And there are GitHub issues which track specifications and also the code in the converter. And you have a very central place to discuss directly with people doing the spec. Early support and adoption. So there is a new JavaScript framework which allows you to make modern JavaScript application, and there is a prototype viewer using this framework in the Khronos repository. And there will be more things coming to use glTF and Collada in a very easy way and seamless. There is Cesium, but I will let Patrick talk about it. And also we have now 3GS loader in the glTF repository, and we will of course reach out to 3GS people to have that integrated. So some demos now. I do the first one. It's a very quick, just to show you something. It's okay. So this guy is 50,000 polygons. It's a SketchUp model, so they are very heavy most of the time. And you have different options to load because you have the scene graph. So before having the binary blob, so typically when it's something that takes time to load, like if I reduce, I am in local here, so we can try that. So you see the bounding box, and typically if you had a very big lever, you could get information about what's visible in the first one first and stream that first. Another thing. So say you have this TV set. Here you get the material from the Collada command profile. a common profile. But it's glTF is about GL, so you can assign whatever shaders in the pipeline that you want in the asset. So here, you have a beautiful shader made by Inigo Kies, and it could be your own stuff inside too. So that's it. Okay, thank you.
Okay, so I'm Patrick Cozzi. I'm a software developer at Analytical Graphics. I'm a longtime C++ and OpenGL engine developer. I came to the web, let's see, how's that look? Because of WebGL about 2 years ago, and I make a virtual globe engine. So think like maybe Google Earth inside your web browser, so global scale rendering. My company in particular cares about satellites. Where are satellites? Where will they be? What can they see? And we care about, we compute that data on the server and stream it down to the client with JSON, do some interpolation client side. So we do 3D, we do 2D, looks like they changed this on me recently. We do 2D and 2.5D. But as you can see, these satellites here, they're kind of lame if they're just icons, right? So I'm really interested in 3D assets, right? Because I want to draw models, or I want to have solar panels that point towards the sun. So, I started thinking about, well, how am I going to do that inside WebGL? And I started coming up with a format to do this that would be tuned for WebGL using JSON and binary data. And I started coming up with server-side pipeline to optimize that. And then I saw Fabrice's work and said, wow, you're doing exactly what I want to do. So then, as Fabrice said, one Sunday we did a hackathon about noon. I took Collada to JSON, and later that night, maybe like 10 o'clock or so, we had geometry, and then by about 2 in the morning we had textures. Not a completely compliant implementation, but something that that did work. And then we did some optimizations to it for a partner of ours, and then this demo here was shown at IPSC back in December. So a partner of ours is called VTMock. They are a simulation company in Boston, and they do a lot of stuff with military simulations. So here again, they use Cesium and the model support using glTF, and they have they're pulling back military simulations for, let's see, predators, aircrafts, and some tanks. So they have position and orientation information. So you'll see this thing kind of tilt as it turns. So they gave us a bunch of assets, and then we made sure that they could render. And one thing that was really interesting was, let's see, I'll show you guys some different ones. The tank's kind of cool. Was some of these models were authored in SketchUp and export to Collada, and they had one triangle per primitive, and there would be like 600 primitives inside a mesh. So in a native app like Google Earth written in C++, which I assume doesn't do very many optimizations when it loads the Collada data, it rendered really slowly. But what we did on the server side was we flattened all that so that the WebGL just did a single draw call, and it was much faster. They were at IPSC saying, oh, the WebGL is faster than Google Earth, which was because the content pipeline on the server side did all the optimization. So the client side code was very simple. I'll show you a few more models. Now these, I did not author these models. Some of them look kind of oh, that's cool when it goes and turns. Some of them look kind of funny to me, but it's just simple Lambert shading with a diffuse texture map. And then in the background here, we're streaming terrain data. We do worldwide terrain. This is 30-meter data for Hawaii. And the imagery here is probably about 1 meter data that's streamed from, in this case, probably Bing Maps. So yes, that's the demo. Any questions? Yep.
Just the random thoughts, I guess. It seems like, the military side of things, this could be very interesting for combining real-time data visualization with augmented reality. Mm-hmm. Have you explored that or thought of?
Yeah, you know, we haven't, my company personally hasn't looked much at AR. I know that in general, Khronos is very interested in AR, and I agree that I think that there could be some interesting synergy there, but we haven't looked at it personally.
Yeah, I agree. I mean, we do talk to a lot with the AR community, and they're definitely interested in this, along with everyone else.
The other comment we were talking earlier, there's something called D3, data-driven documents. It's JavaScript over SVG. Great for 2D. They do a lot of map stuff, love maps. 2D stuff, they don't seem to be really that interested in 3D stuff, which I don't understand.
Right.
But something like this, to bring that together, the
Right.
potential to, you could cast a very wide net
Yes.
by providing that sort of, whiz-bang stuff for them.
I agree. And actually, one of the liaisons we're talking to about augmented reality, the geographical part of augmented reality, is the OGC, Open Geospatial Consortium, because they work in that space too. And they are looking to go more, as you say, go more 3D, and they have some 3D already. But they actually want to work on some of the payload compression for terrains and stuff like that.
One other comment, there's something called T-Query. It's jQuery meets 3JS. And it's Thierry, I forgot his last name. His Hello World sort of demo, he can do a rotating torus in 2 lines of code. Very, very impressive. So that's another area opportunity to reach out and cast a wide net and provide something potentially large community that you
Yes.
could draw in.
Yes, that's a good idea. Because I think the success of this is going to depend on that outreach and
Correct.
make everyone aware that some useful work has been done that people can pick up and use.
Yeah, I think the outreach is really important, and finding key players like that is important. And also, like you said, you can do this in 2 lines of code, right? So it's all about making it easy on the client. And part of the design for glTF is if we will make it simpler for the client, even if it means it's going to be less simple for the server-side pipeline. Because Fabrice is going to write the server-side pipeline. So,
So, I've been doing some experiments, and I've got something that's a tiny bit more technical for the presentation. I'm going to touch into this issue about conformance test and how do you this. So anyway, just try to bear with me, and if you have a question, you stop me. Oh, so you want to make a game or an application, and you want to bring all that kind of content into your application. So you have to get your 3D models, your images, your animation, your physics, and so forth. So how do you do that? If you go, if you try to just do it at once, it's very problematic. So that everybody, when we started Collada, which is a while ago, and it's still the case today, you have those type of content pipelines. So the order is just one that I've selected for that slide, but the idea is that you have to have your modeler, you have to have your animation, you have to have your textures, you have to have, and so forth, and then at the end you have to optimize and you have to package so you can deliver. And every time you have different tools, different format, different hacking, and it's called a pipeline because it just goes one way. And the reason we came with Collada is because that cost a lot of money at the time I was working on the PS3. And I thought, maybe there could be more collaboration between those things, and maybe more companies could provide maybe tools to do some of those things and so forth. So the idea, the only difference on that slide is like everything in there could be maybe one language. So there would be no need to create a different format for each of those things. Maybe there's a way to create a language that can support all the different stages of the pipeline. And that was called the intermediate format, and we created Collada. And it does support all that. It does support the format that comes out of the modeler. You can do polygons with holes, which very specific use model, and down to single triangle, one index per vertex and compressed and everything. So it does support all of that, and that's what Collada is about. Now, what we did too is we came with a tool that's from 2007. It still exists. The source code is still there, still very useful. And we came with that tool, which actually take all the different stages of the pipeline that we showed before, and you can actually take those things and then pipeline them into a processing script. And we provided access converter, stripper, image conversion, de-indexer, triangulation. One of the things that I still use every day is the coherency test, which runs the schema on the Collada, and does more than the schema test, actually validates the index or exist and so forth. So there's a few, actually, because I'm using it, there's a few bugs in there, and it's a little bit of update. But anyway, that's, and we're still doing that, you know, several years later. So, for example, Fabrice has to do some of that into his tool, and everybody is doing the same thing into their own tool, instead of, you know, what we wanted Collada to be, where you Collada in, Collada out, and you do those things into your pipeline. The thing is, at the time when we studied Collada, there was another problem. It's like you can't exchange data between different modelers, and so people started to use Collada as an interchange format. And the other thing is the conformance test that we created. The only way to really do a conformance test on Collada is to be able to compare what goes in to what comes out, and see if you actually understand what I'm telling you, and you can repeat it to me so I can make sure we understand each other with that language. By doing that, we actually put a lot of emphasis on the interchange. Maybe that was a mistake, because the thing got stuck at that level pretty much. So can you interchange with Collada? Yeah, it works completely. You can totally interchange, you know, quads, you know, with quads with the motor. You can interchange animation between animation tools. You can interchange physics between physics tools. But when it becomes impossible to interchange is when you try that. That's not working. And there's no way it's gonna work. I mean, it's nothing to do with Collada. It's like if I speak English to somebody who understands English, and I talk to him about graphics, and the guy that I talk to is I don't know, a music specialist, is not going to understand anything I tell him. And if I ask him to repeat what I said, I'm going to get something that I don't understand anything what he's talking to me about, right? But it's just not possible to interchange data between tools that don't understand each other by nature, right? And that's where, you know, so if you try that, you're going to fail, basically. The thing is, when you try to do an application that loads Collada, you know, how is it to load Collada, right? So if you do a modeler, it's gonna be fantastic. If you export something Collada from a modeler, you have your own modeler, you take data, it matches what you need. But if you do a game or an application and you're like, well, I'm gonna take what comes out of the modeler, I'm gonna display it, then you're in trouble. Because what you're doing here is like shortcutting the entire optimization, the whole transformation path. Right? And you're thinking that you're going to be able to understand what comes out of the modeler and use it into your application just because it's said in the same language. It's not the case. You can't, you know, the application usually wants something that has, you know, specific image format, just one index per polygon, actually no polygons but triangles, it needs to be split, it wants shader programs, and so forth and so forth. You're just not getting that directly from the modeler to the game, or to any application. So you have to have this pipeline somewhere. The idea with the Collada was like there would be more tools available at the different levels, and maybe be able to communicate with each other. And it can work. But what happened really is that applications, very popular application, Unity, I was at the talk yesterday, they have 1.7 million users now. They made it a lot simpler by actually integrating the entire pipeline into their tools. So when you use something like Unity, you actually take data directly out of Modeler. But actually it's simple data. They don't even import physics, they don't, it's just the objects. And then you do everything, all the pipeline within the tool. So it's whatever pipeline they decided to use, right? Because it's not Collada, then there's no interchange, so it's whatever they have. So you have your physics, that's it. You have your shader factory as far as shaders. You have mechanism, animation system. Well, now Unity is very nice. You can actually plug in whatever you wanted and use that as a shell, and then do your you can actually go in there and replace some parts of the pipeline, not using Collada but using the Unity internal data structure for the API. which is limited, right? Because we actually use a model. The internal model is more like the optimized model at the end. Not, you lose the importer will lose all the information. So you can't really make a modeler with Unity, right? But you can still do a lot of nice tools. It doesn't do WebGL. So what do? There's like 1.3 million users. That Unity is a great tool. And how do you get WebGL out of it? If you don't do it, you can't do it. So I was thinking about that. So on the other hand, you have a great WebGL engine. So one I've been using lately, which is nice. It's going to be open source. It is kind of open source. You have to sign up to the developer, you have the source code, but they're going to open source that completely. What I like about them and what's easy for me to use, because we actually have a converter from Collada to their format. Some kind of Collada to glTF, but it's their own thing for now, right? It's not that we're going to be stuck with that. We're probably going to, if we have something that works, we use it, So I'm like, how can we put those two things together? Because they have the problem, right? Their customers try to go from the modular to their tool. And they have like 1,000 lines of Python that they just can't deal with. There's just too much stuff to do. You need to have these pipelines somewhere. So my idea was like, well, let's see if we could actually get those two things together. And there's if you go to Unity, if you have this asset store and you get millions of things in there that people put and you can buy for like $20, for $50, Actually, one of the tools is like a 2D UI for game that the Unity provides one that totally sucks. And so one guy made one and everybody needed that for the game. He made $500,000 in 1 year, selling a $50 tool in that community of 1.8 million people, right? So it's not little business, it's big business. So let's see if we can do that. You take your Max Maya, you go into Unity, in Unity you put your game together, and then the Flare thing is an exporter for Unity to Collada. Get your Collada, go into the DA to JSON provided by Turbulence and go to Turbulence. There's a way now where I have my pipeline, I have my importer, my pipeline, and in Collada to be used at what it's been designed for, being the intermediate format that connects to different worlds together. So that's exactly where glTF would plug into there, right? Instead of having this Collada to JSON from Turbulence, you could plug glTF and you can do Turbulence, 3GS, and so forth. There was a little talk about, I'm not here to talk about REST3D, but the idea of REST3D is to take this and put it on the web, right? Because if you have a way to send your original assets and then for the application to ask for, then there's a potential to take this entire pipeline that I was talking about and put it on the web, and that could be actually a very good way to move forward with getting more users out of 3D, because, like I said, it's just impossible to make people understand that all those things need to happen. It was even professionals, right? They have an issue about, is my content has it been signed or validated? Somebody signed a content saying that this is what you should be using. Is it the one we're using or not? What kind of transform can be applied to it? I mean, this is a huge aspect that has not been solved, and even Unity is not solving it right now. It's just like putting everything together. So the exporter has a bunch of options because you may decide what you want to export. This exporter has a lot more options than the one you find in Max Maya and so forth. But actually, it's pretty nice to have all those options.
And Unity's done this?
No, this is a plugin that you buy for like $15 on the asset store. No, Unity does not. I'm not sure we really like the idea that you can export stuff out of the engine, right. But it's an experiment, right? So
who's done this?
This is a company called Flare that's doing it.
This is right. Okay.
Just Flare, I think it's.
Okay.
Yeah, but there's there's probably others. There's like an OBG exporter. There's like thousands of things in there. Sure. If you Anyway, so I started doing that experiment and I got actually very good results. So I was happy to be able to present it to you today. And so we could look at it with the demos running. We're gonna look at that. So things, I'm looking at content just not exporting just a simple geometry, but can you export animation? Can you have skin meshes? can you, and the answer is yes. There's a few issues that they need to do yourself some API call to attach the weapon to the guy, otherwise it's not attached. There's, can you export physics? You need, games and application have physics, and the answer is yes. You can actually export physics directly out of Unity to Trevett. The thing in the middle is the Apple preview, which is one of the best Collada viewer that exists today, which is double click on the DAE file on the Mac and it just shows what's in there. Well, there's no physics in preview, so the objects get stuck in the air. And then can you do advanced lighting? And so the something like light map, which is very, very important, especially on mobile, for example, can you export that? And the answer is yes again, which although you do need to provide a shadow mapping in the covenants, which means this you need to do a corresponding between what the func shader is in Kada and what you're gonna use on the WebGL. So it's a little bit of work there to do that. Ideally would be that you could actually export the shaders in Collada and then get those back into the WebGL, but Unity is using CG, so and then they have a special way of building it, so you can't really stuff CG inside WebGL yet. So maybe just converters and things like that, but I don't know. Okay, so that's it. So that's the end of the presentation. It's like pretty successful way of because my opinion is like if WebGL is going to be successful, it's going to have tools for it. So right now there's no tools going to take. It takes about 5 years to make a tool that people use. Now that's a tool everybody's using. So is there a way to get it? So that seems to be I was kind of happy of that experiment. So let's see. I don't know. That's the way it looks like in Kubernetes. You have this kind of a local server that runs, and you can see your assets and your game, and you can run the game. And let's see, you can there's this viewer, and then you can click on your model, and you can zoom in and so forth. And so what I did is just loaded the entire JSON and displayed it, and it's actually playing the animation. It's doing the skinning. You can see the skeleton here, and like I said, the weapon is not moving, because the default viewer doesn't have it. Works really well, right? You can do, I don't know, it's just, and they have a conversion tool, you have to know exactly like, you can do some animated data, although there's some bugs, It is, for example, I don't know why in that case. So it's actually shared animation using Collada, which not many in product know how to deal with, which is weird. But for some reason, some of the spiders have like a real problem with it. So some bugs are really funny in 3D. You got weird stuff like that. And then what else I can show you? Collisions are pretty cool. So it has support for all kinds of different collided collision shape, and I tried also more complex things like this chair, which kind of work, but it's weird because actually what they do is they don't yet have support for compound collision volume, and so if you draw what they have actually just this little box here that's attached to the chair. That's the collision for the chair, so that's how it works. Let's see. I have the demo. I'm gonna show something different. I'm gonna show that you can actually use the same exporter to go to glTF, which is, I'm gonna say, of course it's Collada, so it works, but so you can go Unity to glTF, right? I'm gonna show the advanced lighting in there. I had it somewhere. Let's see. I'm pretty sure I had it somewhere. Now that's a different one. That's actually constrained. I was looking at that too, so you can actually, that's the bullet viewer. So it's only showing you the physics part of the object, not visible, and you can do complex stuff like that. Doing that in Unity takes literally 30 seconds to create this model where you attach things and then you have your physics running.
Yeah.
So and so that one is actually it did ask. I exported this thing with Lightmap, and it did put some work on Fabrice because he had to do some more shader generating work in the converter before he wanted to, but I guess he did. And so you have your actually zooming is like that. So let me show you what you can see it, right? All those little lights effects here. Actually, we removed the objects, the light objects themselves. But what you can see here is all the lights effect that are on the wall. Right, it's an added shader. It's because you pre-calculate your light map and you add the light on top of your model. So that's really important and popular way of creating good-looking content, and very important that we support that. So anyway, so that's what I want to share with you. Some good success there to get content into our pipeline, because without content, not much. It's just technology, right? Thank you.
Thank you.
Yeah, I just want to comment, we should definitely engage the turbulence guys, Remi, about glTF.
Sure, this fine. I'm in touch with them. They're happy with it, and they're happy to look at it. Sure.
That's great.
Good. And they are aware of it. They in one of their talks, they talked about God as Jesus at the time.
Yeah.
So I think we're getting there.
So I think that's the end of the presentation. So
Yeah.
where we wanted to end up is just open it up for a discussion and figure out what we can do next. So Fabrice, you might explain some of this, but this was what I came up with this morning. So, and we were talking earlier, we have the OpenCOLLADA stuff. So for the tools vendors that don't have good import-export, you need to be banging on their doors now and persuading them to get their import-export.
They actually do. I mean, the last I tested it, I mean, company like Unity, for example, they do a lot of import, and they do have so many customers, a small portion of them still are using Collada, because they don't only do games. In that space, actually non-game space, it's mostly Collada.
Yep.
And so we had to, because we have this relationship with OpenGL, we actually open a bunch of bugs on OpenGL. Although, lately I opened a bug, but not being able to import a completely file from SketchUp. And I didn't see anybody working on it yet, so we need to push. But summary of that is like, they actually cleaned up a lot of things in the Collada importer. At least the one we use in Unity, but I think it's the same FBX importer that we use in other places. I don't know if it's well connected into the Collada 2 FBX that we use, or the API. So I haven't have time to test that, whatever. But or maybe some people tell me it's because in Unity they do their own import. So it could be. I don't know. Basically, what I'm saying here is there was this idea a time ago that we had that I think is really the way to go, which is, you see, because there's so many ways of exchanging data, and it's normal for a tool not to support a subset of Collada, but what we need to know is what is the subset supported by what tool. Right. And that information does not exist, and the conformance test suite can absolutely generate that information.
Right.
And so what we need is to run performance tests on a few tools, and then publish that information about what's supported, what's not supported. And so it's a lot easier for users of Collada to understand that you're not going to be able to put your physics to.
That's right. That's right. So that's it's kind of the same idea kind of that I came up with. Is that do we create then a public scorecard?
Right.
And a pipeline from the output of the conformance tests. That's kind of what we were talking about earlier. And the naive thing is saying, well, everyone needs to reach a bar, but perhaps you're right. Perhaps that's too simplistic. And perhaps the reality is going to be a scorecard.
I think the idea of the bar that we created at the time was to say, okay, that's what we think is going to be the bar, and we made some of the bars. But the idea was like, we're going to wait for the community to tell us where we see those bars to be.
Right.
That never happened, but that was kind of the idea. I mean, we were like, the basic one is basic. So I mean, that's the one. Maybe I don't think there's much to do into the basic performance.
Right. Everyone should get there.
Yeah.
Then we can go past it.
But then the rest is kind of options, and you pick from whatever what you need from the different tools. It is not simple. I mean, like I said, this pipeline thing is just it's nothing that can convert automatically from A to B. And same thing for glTF. is it going to be able to import everything Collada can export and convert it to glTF? I don't. I mean,
Not to start, for sure, not initially.
I don't even know if it's interesting actually to do that, because maybe you have some other tools that you can use to clean up the data before you put it into glTF.
So that does seem like a good thing to do then, right?
So yeah, it's a little bit of work to do as a test, and then it's a we could start with OpenCOLLADA and Autodesk Collada, so people can see if there are differences on that. And then there's a little bit of work to put that in a web page that's visible, because it's kind of, it needs to be solid somehow, because it's like this huge gigantic.
It's a lot of data
yeah.
that comes
Yeah.
out of those.
Right, so there's some cleanup to do there, some manual work,
Yeah, I agree. It needs some rework. It would be good to have also some. It's very technical detail, but it's all in Python and all that. So one bridge with JavaScript would be great. So we'll see. But yeah, having the ability to publish tests and compare engines would be great.
Yes. Yes.
Sort of, this might be overkill. So there's can I use for HTML?
Yes.
Something.
That might be too fine-grained granularities because it's going to be work to curate such a site, but maybe a coarser level of
Yes.
batch performance and so points, or browsers, everybody wants to have the most points.
Right.
And we do get that level of data out of
Oh,
the
you-
components test suite. So what's
It's possible,
meaningful
yeah.
for visualization, that's a decision
Yes.
to be made, but we do have that input data.
Perfect.
So,
Perfect.
Yes, but that's a great analogy actually. I go to can I use it all the time.
yep.
Another thing, has anyone from the Khronos group reached out to Adobe?
Yes.
I'm
I'm having dinner with them in an hour.
Excellent, because you know about the work they're doing.
Yes.
And the potential sponsorship from them, obviously a huge market.
Yes.
And their movement toward the filter support, CSS3, web developers, it could be huge.
Yes.
What they could do for
And they're really they've talked, but they're beginning to walk now. They're really pivoting into zero support for
Yes.
open standards. So
Excellent.
Right, so there's a connection already between Kada and Photoshop. Right? They use the export Photoshop, but the connection did not exist inside the company.
Yes,
And
right.
I don't think it exists. At this point, I don't think it exists.
it's coming. I think, yeah.
Yeah, we're very
Not
happy
quite
at the
there
tool level if you can make some progress at the higher level, then
Yes.
that'd be
Yes.
great. Yeah.
Yes.
The Photoshop team itself is very firmly committed to Collada.
Yes. Good. But it's a Flash team that's being pivoted to now, so it's good. It's a good thing.
Yeah, well, I mean, the game industry did not evolve mostly for business issues. They did not evolve the way we were intended to do. But it's always like that when you make a plan,
Right.
But what's happening is on the server side. I mean, XML is the king of the server side. And when you do HTML, you have to have a server. You have some of the devices. You need to be providing content. Everything is getting standardized on the web, and more, even as we understand now that, or even Intel, right, that if you try to push something that's your own, then others will push something that's their own too, and nothing's gonna ever happen in the web. And only pushing standards over this long, and will work in the web, and I think companies are understanding that now.
Right.
That they need to be behind standards, otherwise it's not gonna happen.
Yes. Yes. Okay, well, that's good. That's something tangible.
One other comment. It seems like you almost, if such a person existed, to have like an evangelist who could reach out to different communities and try to get that sort of level, see what the level of interest is, and then pursue the ones that seem to be most likely to get some
Yes.
traction.
Yes.
Adobe is obviously one place, but there could be other
That's going to be
sorts of
interesting.
things. I don't know. It depends on people availability, obviously, too.
Yes. No, I agree.
I was going to suggest, some of you will be soon getting to know Ehsan Kamrani. he's not perhaps the right person to interact at a corporate level with some of these opportunities. But Ehsan is a developer based in Iran. He's been a pen pal of mine over Khronos activity for our entire existence. He's done several game engines based on Collada, and I'm on Instant Messenger with him right now. He is so sad he is not here with you. He is so sad.
Well, we're sad that he's there.
He's working on getting out,
Yeah.
and we're doing anything we could to help. He does wonderful work. He has signed up to work for my company as social media for Khronos in general. He's passionate about Collada. He would do anything to help reach out. He's holding meetup groups in Iran with universities and game developers. They have a very strong community there. He's getting a lot of people together. My
So
point
Fabrice, I
was,
think you should go present there.
my point is, although he's very far, hang on, you guys need all the help you can get. Although he's very far, he's been doing this unpaid for years. He's very passionate. He gets professors together. He translated which book was it? He translated one of our reference books. I think it was OpenGL, one of our publications a couple of years ago into Persian, so that they could all use it. And he's written several books on Collada and OpenGL.
He's a true Collada champion.
He really is. He is so devoted and dedicated. So I wanted you guys to meet him, over email, and he's an
Yes, I'm sure we will
evangelist,
to that.
but an official part of our community now.
Yes.
We're still figuring out how I can pay him, but he doesn't seem to care about that. That's how much he cares. So I caught my ear when you were saying we need people to help
Yes.
reach out.
That's a good point.
He's
And I
ready.
mean, I'm sure there's lots of people around the world.
Yes,
We need to find them and bring them
connecting
in.
the dots with
Yes,
those.
exactly,
Yeah.
exactly.
Yes, just in the last couple of days, he's shared some incredible ideas on email. We had to ask him to stop until I can get home and brief him, because he just reinvented the whole kite program without me.
Yes.
Yes, I'm working on a project which is actually not graphics 3D asset related, but it is still 3D asset related, but going from digital to the physical world. And the problem there is that right now, you work with STL or G code as the only representations available. Both of those formats really they don't allow you to correctly model your assets. There's a lot of computation that needs to be done on either before you get it there or after you receive it. Is Collada looking at addressing the physical 3D assets? Because this is a huge community, there's a lot of open source work going on in that community. There is a very large, growing commercial sector there. The problem is that
You mean that this is the maker community, like that?
the maker community, there's several different communities within that scope, yes. The biggest problem right now is that there's no format available for truly transferring 3D assets from the point where you actually create it to the point where you manufacture it. And the other problem is that there's no standard that allows you to put in commercial attributes into the transfer of assets. And when I talk about commercial attributes, I'm saying I purchase a license to manufacture 5 of these assets. Now Collada, the information that's in Collada is very good as a starting point for manufacturing. I think Collada actually has a lot of potential going into that world. Is this something that Collada has looked at all or considered?
Is this what Marcus is doing now?
No, but okay. So what we did already is we worked with a group that's called Automation ML, and so Automation ML have the same problem in actually not manufacturing object, but creating a world of robots that have constraints and know where they are, and actually they manufacture the cores. So it's slightly different problem, but
Yes.
and we said, oh, it would be nice if we could use, you have like 80% of what we need, but
Right.
we need those things, and I'm like, well, we don't know anything about your world, but here's what we can do. we can work together to add what you need to Collada, and then you take Collada and you make your own format on top of that with things that have, that are completely specific to your work.
Sure.
And that's what we did. So we created Collada 1.5. In Collada 1.5, you have inverse kinematics, which a lot of game developers hate because it's inverse kinematics for robots, not for games.
Yep.
You have which can be converted, by the way, but whatever. And then you have MathML, not used as a rendering, but used as a calculation engine. And you can actually use mathematical equation to describe any physics constraint. Like you can make something that when you turn it, it moves forward or things like that.
Right.
So we did that in Collada because those made sense in Collada as a pure description, and then we added a bunch of things on top of that, which was, programming language for robots and things like that.
Yeah.
And it worked really fine, right? We had this agreement with them. They helped us doing 1.5. Yeah. So I mean, maybe 1.5 wasn't the right name for Collada, but that could be Collada automation and video automation in there or whatever. But 1.5 was really successful though because we added all that in there. It was the perfect format for CAD display after that.
Yes.
And that's why it was adopted by ISO because we need the CAD format, and we had a lot of people that have been working with CAD format for a while. And when we came in with Collada, they said, "Ooh, actually, it's simpler. It's got everything we need already." So, but we were like the last one to come in there. That was pretty funny. So I would recommend exactly the same thing, which is create a print. What is it? I mean, give it a name. I don't know, physics ML or whatever that is. Object ML, printing ML. And then see what you can use with Collada, see what you can't use with Collada because it's not what you need, and to be transformed. See if you need, I would start with 1.5 in your case. See if that works for you or not, and if you need more, then let's see if we need to add to 1.5. Push that to ISO.
Because I think this is an excellent opportunity for Collada to actually take charge in the industry and
in a new area.
In a new area that has not been defined yet, but where there is a specific need for a standard.
Yes, that's a good idea.
I mean, we have an extensions process that we kind of nailed down last year. You could, even without doing a whole new rev of the spec, you could just do an extension or a series of extensions that are geared towards that market. And that could directly float into what is existing.
Yeah, you could say my spec is Collada plus those extensions.
Right.
That's my spec. It's called physics ML, and then that's it. Yep, that's your spec.
And I wonder, Remi, maybe you can confirm that in 1.5 there is a concept of bridge to plug different systems.
Right. Well, it's about having each system can have their own schema, and so you can actually include a schema in the schema, right? I don't know about the practicality of that because even some of the current tools we can't even read the Collada schema as is. Because they think there's like loops in there or something, they're just crazy. It's the XML technology has kind of evolved to the point of they're happy with it, and then they did not, go further than that. There's not many people doing 3D in XML that really is worth looking at it, and so we actually use more XML features than is really supported by most XML tools. So. We follow the XML spec, we can do multiple schema, and it should be validated now. If there's one tool that works with that, I don't know.
No, but that's a good idea. It's okay. You have two good ideas: scorecard and outreach to the printing community.
Well, not just the printing community, the import community also, which the 3D scanner, because that's where it really starts. And
that's going to be interesting anyway now because it's just going to go and you'll have a 3D model.
You need compression.
You need compression.
I looked at one of those the other day. Yeah.
I have an off-the-wall thought. It's something that seems to be becoming very pervasive. I think could be interesting is Collada meets 3D printing. Apparently there's...
Yes, that's exactly what I'm talking about.
Okay, because it's going to be disruptive for manufacturing.
It is.
That's sort of true. That's the word
That's
Then-
the exact thing
Okay.
that I'm talking about right there.
So it wasn't so off the wall.
No, it's not off the wall. You're dead on.
Nailed to the wall.
See what 3 beers can do to you?
And that's what I'm talking about, the whole commercialization of assets. Because in the digital format, I will buy a license to use an asset. And it's usually not time constrained or rendering constrained. But in the printing world, if I'm printing an asset, I want to be able to license you to print 1 copy of it. Or you can print as many copies as you want, and I'm going to charge differently for that. It may be that you can print for 5 days. So you have access to that
This
information.
very flexible printing on demand structure.
Exactly. And that there's a huge growth in the commercial industry of printing on demand for 3D objects. And my thought behind that is, why I'm introducing this to Collada, is that if there is a standard for how you render things in the 3D sphere of games and other 3D applications, being able to take one of those assets that I've created for a game and being able to, for instance, I play my game, I get all the way through to the end. The prize is I get to print 1 figure of my character.
That's a good incentive.
So now I'm using that same data model that I used in the game to simply send it out to the printer.
It's going sort of the transition from virtual goods to actual tangible real goods, sort of kind of in the game space.
Exactly.
And there's already, most of the printing website, right? You can load Collada in there. They have Collada converters, and you can already use Collada there.
You can use Collada, but the commercial aspects are missing there.
Right. But that's,
And also the,
I'm not sure we wouldn't actually put it in Collada, or is that
That's right.
that's a
Yes.
DRM layer over the top?
I
That's
think
right.
it's a DRM layer or extension, something.
I'm not sure we
Right.
want to get into DRM.
But the other thing that is not, when you go into Collada, and this is actually one of the big problems with STL too, is that there's not material definition. As far as when I'm doing complex objects, being able to take right now the definitions are this is the shape of the object, but I want to be able to post-process that shape and do structural calculations on it and optimize the reduction of printing material that's used.
right. I mean, you just have the
There is
problem
no
of knowing
standard.
if it's printable or not.
Yeah.
Some
and-
objects
and
are
right-
just not printable.
And right now there is no standard that I know of that handles that problem.
Are there algorithms available to do those calculations?
There are. They're all proprietary. And they're available in $300,000+ units.
Okay.
No, that's a good idea. You're right, that's going to be a disruptive technology.
Yeah.
Any other ideas? I mean, 2 good ideas is pretty good.
Yeah.
Let's go for 3. I mean, I think it's just normal course of business though. Once we have glTF, a little bit firmer, reaching out to the tools guys and the pipeline guys and the engine guys is obviously we need to do that. So
It's going to be easier. glTF is designed entirely open source. Discussion is there. It's so easy because we go through it and get it going. The web community is
pretty connected.
walking that way, and yeah, it's not, Collada was designed closed door, designed it open door. It's going to be very different. Well, to me, glTF would be a success if people take from it. Even if they do their own stuff, they take from it, and especially things like compression, right? That would be already a big success. A bigger success is to have bigger success. You need a bigger ecosystem where people can actually have a tool that let them put together a scene and push a button and see it in the web browser. That's the only way. Overall, the glTF, WebGL, whatever you name it, ecosystem. I don't know how that's gonna happen, but maybe Adobe will do it.
REST ready service would be good.
There's 3D included. Yeah, there's a lot of different pieces of it that are needed to be put together before. I mean, look, think about YouTube, right? You take your phone, right? You take a video, push one button, and it says send to YouTube.
Yes.
That's what you need. I mean,
Yes. Well, no, you're right. I mean, this goes back to that diagram where we haven't had our YouTube moment yet in 3D,
Right.
and you need it's the circle, right? It's the creation. That's hard, right? Because it's specialized professional authors. I need to be able to, scan my shoe and go to eBay and say, find me a shoe like this, right? Then it becomes social, and you need to transmit it, and it needs to be compressed. Then one wants to pay for the bandwidth, and then you need to store it, and then you get this virtuous circle. That's
right.
the
There's
social
some
circle.
shortcut to that. There's objects library and showing objects. I mean, many people like do mashups and things like that. They don't necessarily want to model or anything or
Right.
take a picture, and so you do have a large subset of that circle that you can do with limited set of technology before but we
We're getting there. The bits are
Yeah.
coming into it. Collada's there.
yeah.
glTF will be there. WebGL is there.
Yeah.
So
And
you can
then
display it.
the YouTube moment happened too before it was so easy to do that on your
Before,
phone, right?
yeah.
In the beginning of YouTube, you had to have a lot more gear,
Yeah,
a lot
yeah.
more software to get it there,
Right.
and only since then it really became
Exactly.
ubiquitous in
Well,
everyone's hands.
So the gap in how many users use it is basically when it's iterating on the phone and
Right. Now it's volume, right? So.
Here's another thought. What about a WebGL-ish Collada version, animated version of Instagram on the web? Imagine what you could do. I mean, this could be the future of course, but I mean, I still don't get why Instagram is so popular, but hey, it is what it is. So something like that, like a one-click deployment, push kind of brain dead, drop dead simple.
Yes.
Even I can do it.
Yes.
People will love it.
Yes.
That's the marketing aspect of it.
Yes.
I think that's important as well.
So do you mean Instagram for 3D or
Yes.
upgrading Instagram using 3D?
Either. Essentially say, this is the real stuff, not the
Yes.
2D, but something that you could do. I mean, people go crazy for that.
Yes.
So one thing I've seen people spending quite a long time, a lot of time with that, people actually wanting to create such content was in digital books.
Uh-huh.
Because they like to have the picture animated or 3D, or you can look at objects in a catalog in a book. Those would be the things that could be easier to start with and still have a lot of publishing of books with 3D, right? I mean, you've seen that with PDF with 3D inside.
Right.
You've seen that with iBook, right? iBooks, which actually take Collada to go in. And so I've seen that with Scaleform. We do that too. I mean, everybody wants to have some kind of way to publish books with 3D stuff inside.
They're getting WebGL in PDF. That would be rather than the 3D they're using at the moment.
Right. Cool.
You know, like JS Fiddle, essentially, but WebGL version embedded in a document.
Right.
Real time on your.
Goosebumps.
Anyhow, I just immediately I think it's all the indie developers say all these people doing things on iOS, Android, and who makes money and with little games, and they want to spend time on the logic of their games and not on the content pipeline. So glTF will be immediately, even today, usable for them. So that's really basic stuff, but it's touched a lot of people.
And do you think that they know, or they will know? Remi's point, are we?
That's our work.
Right, I know,
Yeah.
but how should we, I mean, is it just going to happen, or do we need to take some proactive steps, do you think?
I think we need to reach out, but it's not hard to find questions about people. How do I get this 3D asset into my application?
Right.
So we need to be a bit proactive in this area and elsewhere. But there is definitely a lot of room and opportunities in that field.
Well, it would be nice to have a server that would be Khronos paid for, which is not very expensive actually, that simple API and you get models and you can play with the Explorer and change parameters. And because it's kind of glTF button is like to you know, it's like source code and to compile it or even binary, do write libraries and so it should be like
so you mean just
server.
upload a Collada file and get back a glTF file?
Sure, and we can play with the parameters. And,
Sure. That would be interesting.
Yeah.
that would be simple. It's just an Amazon server, put that in there, and then people, you don't even keep the models up there.
Right.
Right? It's just service, no
Right.
better.
Right. Because I did use a video converter the other day.
Like,
It's like, you know, just need to convert this video. Oh wow, it worked.
exactly. So it should not be too much money for us to get there, and it's very easy for us to put it up there.
Sure.
Yeah, that'll be a good investment, and then you give the URL to whoever's making a WebGL and we can immediately convert that stuff without having to.
So think about it.
You know, that would be so fantastic.
Yes.
Right. First model's free.
Yes.
And then Khronos makes money on a conversion fee. Why not? I mean, I don't mind that.
Yeah, I think that's the best way to have people using the tool. It's easiest.
Yeah, exactly. That's the whole
Interesting.
way in now. I mean, even things like Mixamo, which is actually a plugin, they have this tool that remap animation in a different way. They have an API which actually calls in the cloud and sends the data and sends it back. That, you know, they don't even port the software. They just like send stuff in the cloud and comes back, right?
What's that called again?
Mixamo, for example.
Makes them right.
Where you know, and the reason for that is like, I mean, it's just so much. I mean, they have optimized code using GPU, whatever, that runs very fast on the server, and you can't port that everywhere on all different languages and whatever. It's just too much work. So it's better to do a good solid. And plus, we can say, oh, who are you? Oh, okay, you have the right to do it. Oh no, you know, you have to pay per transform, or you have to pay per whatever, right? So there's business model behind it later.
Right.
I mean, the Khronos thing could be, well, we only accept, you know, one conversion per hour per IP or something, right?
Right.
And if you want to do it yourself, then you know, or somebody makes a business out of it or something, right?
Right. 3 good ideas. Yes. A successful meetup.
Yes.
But yeah, that'd be awesome.
Yeah.
There was a website with
Yeah.
what we do.
Yeah, thank you for doing it, Remi. Yeah, I know you're the one who can do it. Right, so
He's your best friend, right? This guy.
I'll do it.
I do the stuff underneath, so.
I'll do that together. It's easy.
I'm not volunteering, but I definitely support it, and I think like it's all about barrier to entry, right? So the converter is great, but someone does have to download it, compile it, and run it, and we can reduce the barrier to entry by then running a website, you know, or also having it exposed to a REST API, right? Those are great things, and across the board, we should be looking for ways to lower the barrier to entry. Like for example, we put the stuff on GitHub, right, and that lowers the barrier to entry. So we should always be looking to do that.
Yeah.
And the great things with web services, we will get a lot of bugs coming, and we will do them. We will have a good quality because we will have some visibility.
Right.
So that's definitely
You get a
good
great
thing.
test set, right?
Yes.
Yeah. All right. So thank you, everyone.
Thank
you
you.
for coming.
Thank you.
Great time.
Thanks for coming.
We have a 3-point plan. We'll see how far we get next year.